Assalamualaikum and very good morning to all the panels. My name is Muhammad Ikram Haiqal bin Hassan with matrix number 197922. Today, I'm going to present to you my final year project with the topic of engineering properties and impact performance of rubberized concrete. Okay, so first, I'm going to go through my introduction. Waste tires increased sharply or greatly with the development of the automobile industry. According to research by ETRMA, the worldwide tire production was 5.1 million tons in 2018. So to the appearance of rubberized concrete provides a new promising method to dispose the waste tires. Crash barrier is a preventive structure that kept the vehicles on the road at their designated lane. So when the vehicle crashed into the road barrier, the impact from the vehicle will cause the road barrier to destroy 100%. So to counter this, addition of crumb rubber is being suggested by researchers to increase the energy absorption of the road barrier. So next, I will go on to my objective. First, my objective is to evaluate the fresh properties of rubberized concrete. Second, to evaluate the mechanical properties of rubberized concrete. Third, to analyze the energy absorption capacity of rubberized concrete. Okay, next, I will move on to my methodology. This is the flowchart of my methodology. For the rubber that is being used to replace the fine aggregate, they will be treated first with two treatment methods. First is now treatment, and second is cement coating treatment. Okay, next for the concrete study, there is 6 types of property that being investigated. For the fresh concrete properties, the test that we need is slump test and the density test. For the hardened concrete properties, compressive strength test and split tensile strength test were being done. And for structural test, 2 tests, which is the impact test and also the drop test. So the picture under the flowchart, and the left one is the apparatus of the weight drop impact test, and for the right one is the setup for the drop test. Next, I will move on to my result and discussion. Before I continue, I would like to emphasize the number of mix design that I use for my research. For this research, I have 7 mix design. The M1 is the control mix design. M2, M3, and M4 design has the same number of same percentage of the rubber content, which is 30%, with different treatment. For the M2, the untreated rubber. For M3, rubber with now treatment. For M4, rubber with cement coating treatment. For M5, M6, and M7 mix design, all 3 has the same rubber content, which is 40%, but with different treatment. For the M5 is the untreated rubber treatment. For M6, the now treatment method. And for the M7 is cement coating method treatment. Okay, I will proceed to my discussion of my results. So the density of the control sample M1 is the highest compared to the compared to other mix design, while M7 is the lowest. So for the compressive strength, of the control sample, which is M1, is the highest compared to all mix design, while M6 design is sample is the lowest. So for the split tensile strength test, the control sample has the highest value of tensile strength, while for the mix design number 6, M6 has the lowest tensile strength. Okay, continue to the structural test. In contrast with the mechanical properties, the mix design number 1 has the lowest energy absorption, while for the mix design number 7 has the highest energy absorption. The same goes to for the impact strength, which is a drop test result. The impact strength for the mix design number 1, the control sample, is the lowest, while for the mix design number 7 is the highest. So as you can see, at the right side of the poster, there is 2 pictures. Both of the pictures shows the look of the crack of the sample after the test being done. So you can see the crack pattern of the failure. after the test being done. So next, I will move on my conclusion. So the conclusion will answer back my objectives that I presented earlier. So the first conclusion is the fresh properties of rubberized concrete will increase as the rubber content increase. The mechanical properties of the rubberized concrete will decrease with the increase of rubber content. And lastly, the energy exhaustion of rubberized concrete will increase as the rubber content increase. So that's all from me. Thank you.